Welcome to the third module in the series Lead-Acid Batteries, which has been developed in association with Seibat Batteries Pty Limited. This training program describes the procedures which will enable you to perform various battery tests and diagnose certain conditions. During the program, you will be given time to discuss and practice aspects of battery testing and fault diagnosis with your course controller. Battery testing should be considered as part of a planned maintenance scheme. This will ensure minimum downtime owing to costly breakdown of machinery or vehicles. Before a battery is considered unserviceable, certain tests can be made to determine its state of charge and internal condition. The first test is a visual inspection of the battery for conditions such as a cracked or damaged casing, dampness or dirt on the battery surface, and damaged or corroded posts. In our next check, the SG or specific gravity test, we check the state of charge in each cell by measuring the density of the electrolyte using an instrument called a hydrometer. The instrument consists of a glass tube into which is fitted a calibrated glass float. The float moves freely inside the tube against supporting guides. The bottom end of the tube is fitted with a small nozzle, and a rubber bulb is fitted to the opposite end. The procedure for using a hydrometer is to hold the instrument in an upright position and insert the nozzle into the cell opening. Gently squeeze the bulb and lower the nozzle into the electrolyte. Slowly release the bulb to draw electrolyte into the tube. Draw up sufficient electrolyte so as to see the float rise freely in the tube. Keep the nozzle in the vent to prevent it dripping acid all over the place whilst you're taking a reading. A reading is taken at the point where the surface of the electrolyte aligns with the color-coded or scale markings on the float stem. Observe the reading at eye level to ensure accuracy. As a quick reference, simply observe the colored markers. If the float rises to the green sector, then that cell is fully charged. Yellow indicates semi or about half charged. Red means the cell is discharged. More accuracy is required, however, to actually assess the SG. For this we have to observe the calibrated scale, whereby a reading of 1,26 to 1,28 ideally means a fully charged cell. A completely discharged cell would read at about 1,000. All cells on a healthy battery should give similar SG readings. If readings vary more than 0,050 points, then the battery is faulty. SG readings may need to be corrected according to the temperature of the electrolyte. A thermometer is necessary to assess this. Refer to your workbook for details on temperature correction. After taking a reading, carefully return the electrolyte to the same cell by slowly squeezing the bulb. The procedure is repeated for each cell. When all cells have been tested, rinse the nozzle in clean water and store the hydrometer upright in a safe place. Whilst performing the SG test, observe the color of the electrolyte drawn from each cell. It should be clear. Any discoloration of the electrolyte is a sign that something is wrong. It may be that the useful working life of the battery has expired, or the battery has been excessively overcharged for prolonged periods, or the electrolyte has been contaminated by the addition of impure water or dopes. Such a condition means that the battery should be removed from service. After the break, we will discuss the load test.